రికార్డ్ అవుతుంది అసలే. హలో
సార్.
ఓకే సార్. సి ఇది ఏంటి వీళ్ళు వచ్చారు సి కాదు. ఓకే.
Good morning, students.
Good morning, sir.
ఇదేంటి వీళ్ళు వచ్చారు ఏంటి వీళ్ళు ఇదెంతకు వస్తుంది C6 వస్తుంది.
Sir, this is ECEC.
ఎందుకు అది సి వస్తుంది సార్, సి వస్తుంది.
Good morning, students. Yeah. So, yesterday we have discussed some problems related to the mesh analysis. So what is a mesh? What is a mesh? Please respond, anyone from the class. What is a mesh? Mesh is a loop which doesn't contain any other loops inside it, right? Are you following or not?
Yes, sir.
Mesh is it audible?
Yes, sir.
Yes, sir.
Yeah. Is the screen is visible?
Yes, sir.
Yes, sir.
Yeah. So mesh is nothing but a loop which doesn't contain any other loops inside it. And yesterday we have seen two mesh problems which consist of two mesh, that means two variables as well as three variables also. So we used the Kramer's rule based on determinants to find out the three variable, that means three currents. Now we will solve some more problems based on some different problems on mesh analysis. So note down this problem. To draw this circuit, So this is the problem to find I1 in the circuit. Did you observe any new element in the circuit which is not present in our earlier circuits? Is there any new element? Yeah, yes, right.
Independent.
Manadeep. Is it independent?
No, sir, dependent.
Yeah,
Dependent.
this is dependent, but so specifically what is this source? It is dependent source only, but it is a voltage source, but depending on current, because its value is given in terms of the current 4I1. So this is current dependent voltage source, right? Specifically, it is current dependent voltage source, because we know that is a dependent source, but symbols are given as plus and minus. So it is a voltage source, but its value is given as 4I1. So that means its magnitude depends on the current flowing in the second mesh. So to be specific, it is current dependent voltage source, right? Already it is given that in the second loop, the current I1 is flowing. The current I1 is flowing in the second loop. So you assume the current flowing in the first loop. The first loop is, take this as I2. The current in the first mesh is I2, because already in the problem, it is given that the current flowing through the second loop or second mesh is I1. Okay. So take the current in the first mesh is I2, right? Now apply KVL. So the same old procedure, you use whatever we applied in the previous problems. So for first loop, 5 volts. So this is the current dependent voltage source. So we will say this is 4I1 minus 4 into I2 minus I1, the current flowing through the 4 ohm resistor, minus 4I2 is equals to 0, right? So this is the equation, KVL equation for the first mesh. Simplify this one. You simplify this, 5 volts plus 4I1 minus 4I2 plus 4I1 minus 4I2 is equals to 0, right? So 8I1 minus 8I2 is equals to minus 5. So this is the KVL equation for the first loop or first mesh. Now apply KVL for the second loop, second one. Minus 4 into I1 minus I2 for this element. For this element, minus 4 into I1 minus I2, this is first one. Next, minus 2 I1 minus 3 volts is equals to 0. So simplify this, minus 4I1 plus 4I2 minus 2I1 is equals to 3. So that means minus 6I1 plus 4I2 is equals to 3. Right, two equations, two unknowns. Now simplify this. Simplify and find the value of I1. Two equations, two unknowns. Find the value of I1. What is the value of I1? What is I1?
Minus 0.2.
Minus 0.25 amps, right? Did anybody got the answer? Is it right? Minus 0.25 amperes.
Yes, sir.
Anybody got different answer or same? Minus 0.25 amperes. Same answer. 4F3, Kiriti. 4F3.
Sir.
You got the answer?
Yes, sir.
Yeah, right. Venkateshwar Reddy, 4D8.
Yes, sir.
Power?
Yes, sir.
Right. Okay. So now I will give a similar kind of problem. So you solve this one. Which again, which consists of the dependent source. Same ohms or I1 Vx. So here I will change this value. I'll change the value. Find I1 and Vx. Find I1 value and Vx. So one more dependent source is there in this circuit. This is the dependent. What type of source it is? It is voltage dependent voltage source, right? It is a voltage source. Its value depends on the voltage. So voltage dependent voltage source. Voltage dependent voltage source. So find the value, solve this problem and find the value, which is almost similar to the previous problem, but the only difference is here instead of current source there is a voltage source. So here two unknowns. If you apply KVL to the first loop, you will get 5 volts plus 2 Vx. Here you can write this as minus Vx or this is 3 minus 3 into I2 minus I1. If you assume the current in first loop is I2, because already in the problem it is given the second loop current is I1. So assume I2 is the first loop current. So minus 3 I2 minus I1 minus 4 I2 is equals to 0. Right. So this is the first loop, KVL for first loop. For second loop, minus 3 into I1 minus I2 minus 6 I1 minus 6 volts is equals to 0. So in addition to this, you can write one more equation, because here 3 unknowns, Vx is there, voltage, because there is a dependent voltage source, Vx. So what is Vx? Vx is the voltage across 3 ohm resistor. Vx is the voltage across 3 ohm. So we can write voltage Vx in terms of currents as Vx is equals to 3 into I2 minus I1, right? Vx is 3 into I2 minus I1. Is it clear? Any doubt is there in that? Because in the first KVL equation, 3 unknowns are there, I1, I2 and Vx. But we have 2 meshes. So we will get only 2 independent equations. So we should know the relation. One more relation is required to solve this problem. That is nothing but Vx is 3 into I2 minus I1. Vx is 3 I2 minus I1. So substitute this Vx here in the first equation, so that you will get only 2 unknowns, I1 and I2, and 2 equations. 2 equations and 2 unknowns. You can solve this problem easily to find I1. So you need to find I1. Since Vx is required, I2 is also. So find I2. So Vx is I2 minus I1. So 3 unknowns you need to find, I1, I2, Vx. This I1. What is the value of I1? Solved or not? Navya? Navya, 4 H not.
Sir,
Solve chesara. What is I1?
చేస్తున్నాం సార్.
Sudhir. Sudhir D. 0.5 amperes. Is it right? Everybody got the same answer? Is it I1, Samsevra?
Yes, sir.
Yeah. I1 is 0.5. He got it I1 as a 0.5 amperes. Did everyone got the same answer? 0.5 amperes, I1. Yes, right. So I1 is 0.5 amperes. Write the units also. 0.5 amperes. So I2. From the second equation, we can find I2. 3I1 plus 3I2 minus 6I1 is equals to 6. So minus 9I1 plus 3I2 is equals to 6. Minus 9I1 means 4.5 minus. So 6 plus 4.5, 10.5. I2 is 10.5 by 3, right? It's 10.5 divided by 3. Is it 3.5? I2 3.5, right? I2 3.5 amperes. So Vx is 3 into I2 minus I1. 3.5 minus 0.5. So 6 volts. 6 and 9. 9 volts. Right? So 9 volts is a Vx. Vx is 9 volts, right? So I1 0.5 amperes, I2 is 3.5, Vx 9 volts. Okay. Did everyone finish the problem? I1 is 0.5 amps, I2 3.5, and Vx is a 9 volts. Very good. Everybody should involve like this. Sam Seora and Sai Sandeep solved and they posted values like this. Everyone should be active. Yeah. So now we'll go through one more variation in this mesh analysis. So this means there is a slight change in applying the mesh equations because usually we'll apply the mesh analysis if more number of voltage sources are present in the circuit, right? Suppose if any current source is present in a loop, somewhere in the loop, if current source is present, so it is difficult to apply the mesh analysis, right? So far we didn't see those kind of problems. Some current source is present in between in a mesh, somewhere in the mesh, right? So suppose if we have some current source in the mesh, that means suppose if I write one equation like this, one circuit, I will show you V this is R2, see, suppose here some current source is present like this, current source is there, or I will tell you the direction, I will change the direction. suppose this is the current I. So if this kind of circuit is there, usually we can apply the mesh analysis to solve these kind of problems. But see, suppose a current source is present like this. So now it is somewhat difficult to apply the mesh analysis, right? So in that case, we will call a new technique which is known as a super mesh, which is called super mesh analysis, or it is known as a super mesh. Super mesh. So this technique is used, super mesh is used whenever there is a current source is present. So to overcome the difficulty in applying the KVL equations, so if current source is present, so in the circuit, okay, super mesh is nothing but, so we will call this mesh. See, this is one, let us say I1 is the current in the first mesh, I2 is the second, I3 is in third. So since there is a current source, we will neglect this branch and we will assume the 1 and 2 together is known as a super mesh. So wherever the current source is present, at which the boundary is present, we will neglect that branch and we will combine those loops, those two meshes which consist of the current source in their boundary. So, and we will combine these two and it is known as a super mesh. Okay. So, but the procedure is same, whatever the procedure we are following for the mesh analysis. That means initially, what is the first step in mesh analysis? We have to take the currents. We have to assume the current directions. That means for each mesh, we will assign one current. Suppose if there are 3 meshes, 3 currents are assigned, and then apply KVL for each mesh. So this is the procedure in case of mesh analysis. Okay. Suppose if you find any current source somewhere in any loop or in any mesh, so then we will take those two loops which consist of the current source as boundary between those two is considered as the super mesh. So now I will show you how to apply. So see, the first one, I1 and I2, these two together as a assumed as a super mesh. Are you following? Super mesh means it is called, whenever there is a current source is present. Suppose if there is a current source is present in the circuit, the current source, then we will call it as a super mesh. We will take the mesh, two meshes together. So wherever in boundary is present, in which boundary that current source is present, we will take those two as the super meshes. Okay. So now let us see the KVL equation for the super mesh. That means, so where I have shown here in red color, this is the super mesh. So the combination of the first two meshes is called the super mesh. Now we will apply the KVL as V minus R1 I1 minus, no need to take this branch. So R3 minus R3 into, so what is the current flowing through R3?
I3.
I3 minus I2. I2 is there now?
Yes.
I2 is also. So I3 minus I2. Sorry, I2 minus I3. I2 minus I3 is equals to 0. See, so there is no difference. First assume, so don't take the initial step. First assign the currents as usual, as we have followed the procedure in mesh analysis. In the same procedure followed here also, except that after assigning the currents, be careful, after assigning the currents. So first initially assign the currents for each loop. Then after that, you made a super mesh. Wherever the current source is present, you made that super mesh, right? So now write the equations here like this: V equals to R1 I1 minus R3 into I2 minus I3. So this is the KVL for super mesh. Then for third last loop, R3 minus R3 into I3 minus I2 minus R4 into I3 is equals to 0. Right? So here we will have three currents. I1 is there, I2 and I3 because three mesh are there. So we got the two equations in terms of three unknowns, I1, I2, I3. So, but we know this relation. What is this one? So we neglected one branch where current source is present. So what is that current source? What is the value of I here? The current source value. What is the current flowing through R2? What is the current flowing through R2? If you take this one, I1 minus I2. So I is equals to I1 minus I2. I value is because it is flowing in this direction as in the direction of I1. Is it clear? Since I is also the direction of I is also in the direction of I1. So actually the current flowing through this branch is nothing but I1 minus I2. So I is equals to I1 minus I2. So from this current source branch, wherever the current source is present, so we can use a relation which gives the value of I, right? So if you know the value of I, this I, you know some relation between I1 and I2, so we can substitute this value and we can solve the equations, right? So just do a problem, one problem on this, so you will get some idea what is a super mesh. First, if you want, you can write some theory on what is a super mesh. So put a heading like super mesh analysis. Write down what is super mesh. Super mesh. Suppose if any of the branches in the network, suppose if any branches in the network, suppose if any of the branches in the network contains a current source, if any of the branches in the network contains a current source, then super mesh technique is used. If any of the branches in the circuit consists of a current source, then super mesh technique is used. Then super mesh is used. A super mesh is formed by two adjacent loops, that have a common current source, right? So this is, in this way we will use the super mesh technique. Okay, so whenever while applying the mesh analysis, if you find any current source on any branch, then we will form a super mesh. So by combining the adjacent loops, so which has a common branch with the current source, right? So now you note down a problem and solve this one, you will get the idea on super mesh, how to apply the super mesh analysis. Note down this circuit, which consists of three loops. right? How many loops are there? Is it visible, the circuit? How many loops? 3 loops. So first assign the 3 currents, right? First assign 3 currents for the 3 loops. Individually, you assign the 3 currents that are in clockwise. So first loop, for the first loop, assign I1, for the second, I2, third one I3. Okay. So now the super mesh is formed by combining the loops which contains the currents I2 and I3, right? Okay. Now write the KVL equations. For the first, write the KVL for first loop. For the first loop, 50 minus 10 into I1 minus I2 minus 5 into I1 minus I3 is equals to 0. So simplify this one. Minus 10 I1 plus 10 I2 minus 5 I1 plus 5 I3 plus 50 is equals to 0. So minus 15 I1 plus 10 I2 plus 5 I3 is equals to minus 50, right? So if you simplify this one further, and I am taking the positive sign for I1. So 15 I1 minus 10 I2 minus 5 I3 is equals to 50, right? Both are same. So just I have taken the plus sign for I1. So both are same. Just I multiplied the negative sign on both sides. Okay. So now apply the KVL for super mesh. Super mesh is second and third, the combination of the second and third one, right? Second loop and third. Yeah. Write the super mesh, KVL for the super mesh equation. So that is minus 10 into I2 minus I1 minus 2 I2 minus 1 into I3 minus 5 into I3 minus I1 is equals to 0, right? So minus 10, start from here, minus 10 into I2 minus I1 minus 2 I2 minus I3 minus 5 into I3 minus I1 is equals to 0. So simplify this. Minus 10 I2 plus 10 I1 minus 2 I2 minus I3 minus 5 I3 plus 5 I1 is equals to 0. How many I1 terms are there? 10 I1 plus 5 I1. So 15 I1 I2 minus 10 minus 2 minus 12 I2 I3 is 5 plus 1 6 minus 6 I3 is equals to 0, right? This is the second equation. Okay, so that means super mesh is formed by combining, that means this branch we neglected, which consists of the current source, right? So now what is the current here? 2 amperes. So we know the direction. What is the current in this direction? We take that is in the 2 amperes direction. What is the current in this direction? I2 minus I3 is equals to 2 amperes. I2 minus I3 is 2 amperes, right? I2 minus I3 is a 2 amperes. Now we can eliminate one variable from these two equations. Okay, because we know the relation between I2 and I3. So because we have three unknowns, I1, I2 and I3 in the two equations, you convert those equations into equations which has only two unknowns, because we know another relation. I2 minus I3 is 2 amperes, right? Is it clear? Any doubt in this super mesh analysis? Any difficulties there? Please respond. Are you following or not? Yes, right. Now you simplify using this equation I2 minus I3. So you convert I2 minus 2 is equals to I3. You write this equation everywhere. Wherever I3 is present, you can replace this with I2. So the first equation is 15I1 minus 10I2 minus 5 into I3 is equals to I2 minus 2. So simplify this. 15I1 minus 10I2 minus 5. That means 15I2. 15I2 plus 10 means it is equals to 40. If it comes on the other side, 15I1 minus 15I2 minus into minus plus 10. So it becomes 40. Now the second equation, 15I1 minus 12I2 minus 6 into I3 is I2 minus 2 is equals to 0. So 15I1 minus 12I2 minus 6I2 plus 12 is equals to 0. So 15I1 minus 18I2 is equals to minus 12. So after simplifying, these are the two equations. So now solve it. So 15I1 minus 15I2 is equals to 40. Here 15I1 minus 18I2 is equals to minus 12. I2 is equals to 52. So I2 is 52 by 3. I2 is 52 divided by 3. Is it right? I2 is 17.33 milliamperes. Sorry, 17.33 amperes. Right? Did you get the same answer? After simplification, I2 is 17.33 amperes. If you know I2, you can solve for I3, because we know the relation between I2 and I3. That is I2 minus 2 is equals to I3. So I3 is I2 minus 2. That is 15.33 amperes. I3. I2 is 17.33 amperes, I3 15.33 amperes. Solve for I1. So I1 is 19.99. I1 you will get as 19.99 amperes. Right? Did you get the same answer? It's the same answers or not? To solve that, use the three equations. The relation between I2 and I3 and apply nodal equations, mesh equations. Yeah. Now I will take the attendance. Please be online, everyone, and I will note down the attendance. Yes, any doubt? Any doubt? F5, Lakshmi Meghana.
Sir.
Any doubt?
No, sir.
Okay. Respond your roll calls, please. C7.
Present, sir.
C8. C9.
C9 present, sir.
D0.
Present, sir.
D1.
Present, sir.
D2. D3.
Present, sir.
D4. D5. D6.
Yes, sir.
D7. D8. D9.
Present, sir.
C0. E0.
Present, sir.
E1.
Present, sir.
E2. E3. E4.
Present, sir.
E5. E6. E7. E7. E8.
Present,
E9.
sir.
Yeah. E9. F0.
Present, sir. F not.
F1. F2. F3.
Present, sir.
F4.
Present, sir.
F5.
Present, sir.
F6.
Present, sir.
F7. F8. F9. G0.
Present, sir.
G1.
Present, sir.
G2.
Present, sir.
G3.
Present, sir.
G4.
Present, sir.
G5. G6.
Present, sir.
G7.
Yes, sir.
G8. G9.
Present, sir.
H0.
Present, sir.
Yeah. Okay. Thank you.
Sir, F1 present, sir.
F1. Right. Okay. E3. Okay. Okay. E3. Prashant. Right. Okay. Okay, thank you.